Hi, good afternoon. This is Mr. Cassidy, and this is our Chapter 7 review lesson on congruence in similar shapes. So, before we begin, please make sure you have some scratch paper out, as a few of the problems that you're doing will require you to use scratch paper. And just try to follow along. After each problem, I'll go over the answer, and so make sure you're trying to understand whatever it is you might have missed if you do get a question wrong. Okay, problem 1. Looking at shape A here, we have two triangles, a triangle on the left and a triangle on the right. Are the two triangles congruent? You should have said yes. Yes, the two triangles are congruent. Triangle, and we could call the first one TVW, is congruent with triangle UVX. Okay, second question. What transformations would map triangle TVW onto UVX? There are two. Please pick both. All right, and the answer to problem 2 was we would have a vertical reflection. A vertical reflection means we flip it over the vertical line, followed by maybe some translation to get it in the perfect spot. Okay, moving on. For problem B here, same question. First, are the two quadrilaterals congruent? Are they congruent? The answer should have been no, they are not. This quadrilateral is much bigger than this one. It's longer. All right, moving right on to lesson 2. On lesson 2, we're looking at congruent shapes, and we're naming the sides and angles that are congruent. So in the first one, I want you to look at the triangles here. Angle D is congruent with what angle in the other triangle? You should have answered angle B. Angle D is congruent with angle B. Okay. Next, and how we can tell that is because the two marks here in the corner and the two marks here in the corner let me know that the measurement of those two angles match up. All right, here we have another quadrilateral, and I want to know side MP. Side MP is congruent with what side? Side MP is congruent with side XY. And how we would write that is we would write it MP is congruent, and we put a little line over that because that's the line I'm talking about, line XY. All right, you can tell that based on the diagram because there are 4, I call these tick marks through side MP, and they're the same 4 markings here showing me that those are matching amounts and matching lengths. Notice that this means that we could name all 4 corners that are matching and all 4 sides that are matching because the whole shape is congruent. All right, moving on to lesson 3. In lesson 3, we work more with similarity. Now, similarity means not just translation, rotation, or reflection. What change is usually made for similarity? You should have said dilation. And first off, I want you to check, are these two triangles similar? All right, to test your answer, you should label the sides that you can measure. For instance, this is 3 units, and this is 4 units. Here, this one is 8 units, and this is 6 units. And what we want to see is, can you multiply all of the old numbers by something to get the new numbers? Well, I see, yeah, 3 times 2 is 6, and 4 times 2 is 8. Now this triangle has been rotated and dilated by a scale factor of 2. We abbreviate scale factor with the letter K. So yes, these are similar shapes. Okay, how about these two rectangles? Are they similar? I'll test it here. We have side 3. We have side of 6. And here we have a side of 5 and a side of 9. Okay, what we should be able to do is make that ratio new over old. I'll do new here. I'll do old here. And so I'll test 9 over 6. Does that equal 5 over 3? No. They are not equivalent fractions, so therefore they aren't the same scale factor. These are not similar shapes, because one side is multiplied by one number, one side is multiplied by a different number. Okay, carrying on. Here's lesson 4, more about similar shapes. We're going to start just by analyzing, are these shapes similar? You should have said yes. How we can tell is we test by making a ratio of corresponding sides. For instance, side 20 corresponds with sides 10. So I'm going to make a ratio. I'm going to call the bottom one new, other one old. That doesn't affect our answer here. And I'll go 20 over 10 equals 2. Great. Next, I'm going to compare the side marked 8. Well, which side does that match up with? I look for those same 2 corner angle markings, and that matches up with the side of 4. So 8 over 4 is 2. And last, I've got side of 14 and a side of 7. So do those match up? 14 over 7 is 2 as well. Yes, all three sides have the same ratio. New over old is always 2. Okay, find the missing side, x, in this diagram. Okay, and what you should have done is again, I'm going to call this one new, this one old. If you labeled them the other way, it doesn't matter, but I just make sure I'm writing a new over old fraction. So in this case, the matching side, 22.4, is 14. So I'm going to write 22.4 over 14 equals the matching side of x matches with the side 10. So equals x over 10. I'm going to go ahead and diagonally multiply. That's cross multiplying here, which is what we've been doing a lot of this chapter. So I get 22.4 on one side multiplied by the number 10 equals 14 times x. So in this case, 22.4 is 224 equals 14x. And my last step is to divide by 14. You may have noticed that my graphics are very pixely here. The reason why is I zoomed way in so that numbers can clearly be seen on any device here. All right, so on this problem, when I do 224 divided by 14, that's where I would either take out a calculator or do long division. For the interest of time, I'm going to just use a calculator. 224 divided by 14 is equal to 16. So x here equaled 16. Excellent. Let's move on. Next lesson. Next lesson we covered was indirect measurement. Indirect measurement is the same as the last lesson. It's just using more real-life examples. For instance, in our first problem, How tall is Becky? I know everybody's been wondering that, and we're going to find out. Go ahead and solve for h. And what you should have done is done corresponding sides h over 3 equals 7 over 4. We cross multiply diagonally. H times 4 goes on one side, or 4h, equals 3 times 7 on the other. And when we get that, we get 4h equals 21. We divide by 4 as our last step. And when I divide by 4, I get h equals 5 and 1/4, or 5.25. Okay, next problem. Here it's a little bit trickier because the triangles are reversed, but go ahead and try to solve finding how wide is the distance between the band room and the gymnasium D. Okay. Again, I would write D over 32, because that's the corresponding side, new over old, equals 30 over 25. I would diagonally multiply here, and I get 25D equals 30 times 32. Okay, 25D is equal to 960 here. And when I divide by 25, I get my answer. In this case, let's see here, D is going to be equal to, let's see here, 25 goes into 900. 36, 37, 38. Looks like 38 times and 10/25, or 2/5, which is the same as 38.4. We want to use units here because we've got units in our problem, so we're going to call it 38.4 meters. Okay. Moving on. Last lesson of our chapter, lesson 7-7, perimeter and area. So perimeter works the same with scale factors as similar shapes. Find the perimeter of the new shape. All right, what you should have done is first found the scale factor. This is always going to be our new shape since we're missing its perimeter. And what we want to do is, what is the scale factor to get from 6 to 18? How we do that is new divided by old. 18 over 6 is 3. That's our scale factor. So the new perimeter is 3 times the size of the old perimeter. In this case, I have 18 as the old perimeter times that scale factor 3, and I get 54. So 54 inches would be the perimeter of the new triangle that is 3 times the size of the old triangle. Awesome. That concludes our video for review. Thanks for watching, and I hope you have a wonderful math afternoon.